Hello and welcome back to the Arduino Python series. And this is tutorial number 30. In lesson 29, we built a light beam object counter that displayed a real-time graph of the beam status. Today, we are taking it into the next level. We want to add, a touch sensor to switch between two different HMI screens. Also, we want to add a buzzer and an RGB LED or SMD, or if you don't have, RGB modules, don't worry, you can use, three different, color LEDs to give just audio and visual alerts. Also, I want to just, add a second screen that shows a scrolling log of events. For example, I want to see, the object detections, durations, alerts, and other things, other information that you want to see on your HMI, on your screen. So now you have a complete industrial style monitoring system. You can watch the real-time beam status on one screen, and you can tap the touch sensor to switch to a log panel that shows a history of what happened. If an object blocks the beam, or if the object doesn't block the beam for more than 2 seconds, 1 second, or whatever you just want, we can just turn our RGB LED into the red. The buzzer sounds, and an alert is added to the log. But I want to just do the second scenario. I mean, if the object doesn't just block the beam for more than like 2 seconds. I want to do all these things to show all the alerts, but as I told you, you can do whatever you want. But for for this demo, we want to do this. So this is the kind of interface that you would see in a factory control room. By the end of this video, you will know how to create multi-screen HMI dashboards, log events, and trigger alerts. So let's dive in. Okay guys, so for today's hardware, so we had the light block sensor from the previous lesson. So we don't just change anything here. Okay, so now let me just put them here. This is the 5 volts and the GND from my Arduino board. So the first thing that I'm gonna add today, this our buzzer, the buzzer module. But don't worry, if you don't have a buzzer module, you can just use passive, normal passive buzzers. Okay, so my buzzer, as has 3 pins, but we don't work with the middle one, so we only need the GND and the plus. Plus is our signal pin. Okay, so I'm gonna just connect my buzzer like here. Okay, I'm gonna put it here, and the GND goes to the, let me see, this was, yes, this pin, this is the GND. Okay, so this is it will goes to the negative, let me put it here. Okay, so it goes to the negative side of my breadboard. And the pin and the S pin. Okay, just be careful guys, not the middle one, not the middle pin, just the third one. Okay, so the third pin, the last one, goes to pin number like 3 on my Arduino board. All right, the next module, I want our touch sensor, our touch module. So our touch module, it has 4 pins, as you see, A0, G plus D0. We explained this module in previous lessons in much more details. So today we only work with D0, plus, and G. Okay, so let me just put it, for example, like here. Okay, all right, so this pin, this is the D0, so this pin goes to the D0. Okay, let me just, okay, so D0 goes to pin number 4, okay, of my Arduino board. And the next pin will be the positive, and the other one will be the G or the GND. So I'm going to connect them, one by one. So positive goes to the positive of my breadboard. Okay. And the next pin will be the G or will be the negative. So I'm going to connect it, to the negative side of my breadboard, just like that. Okay. Now, it's just I have my RGB SMD, but don't worry if you don't have the module. You can use different LED colors. So as you can see, these pins, the last one is the G. The G is common. So I'm gonna just put it like this here. Okay. So this is how I connect my RGB SMD. Now the first pin is the G, is the G. So the first one is the G. I'm gonna connect it directly to the negative side of my breadboard. Okay, so the negative will be just common between all three colors. Now let's just connect the first color is the green color. Okay, so let's connect the G to pin number, so RGB. Let's start with the R, start with the middle one. Okay, R, because RGB I just want to, so R goes to the pin number 5. Okay, G or green will go to pin number 6. G will be the first one up here. Okay, so this will be G, goes to pin number 6, and the last pin will be the blue one. Okay, so the blue one goes to pin number 7. Okay, so this is for today's hardware. This is how we set up our today's hardware. Okay, so now we can just go directly and start coding. Alright guys, so because we want to just develop our previous lesson code, so we can just easily go and open the previous lesson. So the previous lesson was light blocking. Okay, this is it, and now I'm gonna just generate a new file here. So, and I'm gonna call this new file like multi screen.py. Okay, so this is our new file, and I'm gonna just go to the previous lesson code. I'm gonna select all, I'm gonna copy. Now I'm gonna close this tab and I'm gonna paste it here. Okay, so now I have just the previous lesson's code. This is the previous lesson. Okay, so now I'm gonna just start adding or removing the things that I need for today's lesson. So we start with the imports. So the imports will be exactly the same. We don't change anything. In Arduino setup also the same. We don't need to change anything. This is our iterator. We don't need. Okay, now let's come to our pins. Okay, so the first, so beam sensor is the pin number 2. Okay, now I want to add a buzzer, so I'm gonna say buzzer, and I'm gonna just easily copy. Okay, copy and paste this line, but be careful, instead of input, our buzzer will be output, and my buzzer will connect to pin number 3. Okay, it will be also digital, and I also have a touch sensor, so I'm gonna call it like touch sensor. Okay, I paste it, but instead of but be careful guys, my touch sensor also act as an input. Be very careful, do not change this I. The pin number, so I'm gonna connect it to pin number 4. Okay, now I have 3 different color LEDs, or I have one LED module, RGB module. So the first one is, for example, I'm gonna call it red RGB. Okay, I'm gonna say red, I just call it red. Okay, so red connected to pin number the red connect to pin number 5. Okay, red to 5, and the next one is green, RGB. So green connected to pin, just make it O. Green connected to pin number 6. Okay, and the last one is the blue one. So I'm gonna say, okay, out. Okay, it's gonna connect to pin number 7. Okay, so this is our pins. So we don't have any other pins to define here. Okay, so we can go to the next line. Okay, now I came here to my variables. Okay, so these are these five variables. These are from the previous lesson, but in today's lesson, let's just ignore, let's skip with this time history. We don't need this time history, as if you can remember, I told you, it's just we want this variable to just for analysis, but today in this lesson we don't need it, but we need the status history because we want to keep update our HMI, our first screen after 150 sample. Okay, and we want this object count, the total number of objects that detected. At the beginning it's 0. We also want our beam blocked, so at the beginning it's false. It's a flag. If you can remember, it was a flag to track the current beam state. Also we need this block start time, that it was known at the beginning. It's a time step when the beam was first blocked. Okay, so now today we need some extra variables too, so we have to define some extra variables. Okay, so if you can remember, I said today we have two screens. Okay, so we have two screens that when we touch our touch module, we want to just toggle between these two screens. So at the beginning, let's assume that when we run the program, we want to see the first screen. Okay, so I'm going to define screen here. I'm going to say screen. So by default, the first screen will show. Okay, so this variable, it means that which screen is active. One means the first screen. From now on, let's call the first screen the plot, and the second screen we call it message log. Okay, so the first screen will be the plot screen, and the second screen we're gonna call it message log. It's just a name that we put. It doesn't you don't have to exactly to use the same names. I just call it call these two screens plot and message log. Okay, so it means that which screen is active, because these are, if you can remember, these are the variables that we were just updating them in our main loop. Okay, so it means, this means which screen is active. Now I also have the error, or in the message log I also want to print some messages or errors. I'm gonna call the messages that I want to show in the second screen or to the message log. I'm gonna call them errors. Okay, so these errors, it's a counter for objects that stayed too long or they stopped. Okay, this is where our buzzer or our alarm system should just turn on. Okay, so at the beginning, let's say it's, again, this one is also 0. So at the beginning, let's say nothing stuck, and our program, or our not program, our just system, our conveyor, let's say for example it's a conveyor system. Our conveyor is just running normally, nothing stocked, and objects are just passing through the sensor normally. So at the beginning we don't have any error. And also we want, for example, to just show to see a list of all blockage duration, to see for how long, for example, an object just blocked our sensor. Okay, so at the beginning, so now it's completely optional, but I just want to see this blockage duration. So I'm gonna say durations. Okay, and at the beginning, so as usual, it's empty. Okay, because now we're just defining it, but in the main loop we're gonna update it. We're gonna just pass it the data. All right, and just one more thing, in the message log or in the second screen, exactly like what we did here, this status history here. So exactly, we don't want to see all the messages. We don't want to save all messages. We want to see, for example, like only last 5 log messages, or for example, you want to see the last 10 log messages. Okay, so I have to tell the program here, I'm gonna create another variable, and I'm gonna call it messages. Okay, messages. Okay, so messages. And I'm gonna say, for example, I'm gonna use this deck. Okay, this module, I'm gonna say deck. Okay, so let's say, for example, I want to see for today, I want to see the last 10 log messages. So I'm gonna say max len equal to 10. Okay, so it keep the last 10 messages on my on our message log. Okay, or on our second screen. All right, so this is for our variables, and I don't think that we need to define anything else in our variable section. All right, let's just move on to our matplotlib setup section, this section. And if we just if we need something else, if I can just remember anything else, we can just come back and add it here, but I don't think that anything else left. So let's just go and see what's gonna happen, or what should we do here in our matplotlib setup. I mean, because we have 2 screens, so we have to just change this section, or the matplotlib setup as well. Okay, in matplotlib setup, we have okay, with the plt.in, it always should be there, because we have to just turn an interactive mode on. Okay, so but today we have 2 different screens, but when we have 2 different screens, but we have to create a figure first. Okay, when we create a figure, then in the figure we can define 2 different kind of screens. Okay, but how we can define the figure first? So now, if you can see here, if you can remember from the previous lesson, because we only had 1 figure and 1 axis, one just we had just inside our figure, we had only 1 screen. Okay, that's why we just said fig and ax. Okay, but today we want to separate our ax. We want to say, for example, ax1 and ax2. Okay, so first of all, we have to just create our figure separately. Okay, so how I can just define our figure separately? Just here, instead of fig and ax, instead of that, let's just say fig equal plt dot, and instead of subplots, let's just say figure. Okay, so fig equal to plt dot figure, and here we give it the size, the size that we want. So again, exactly, we say we want, for example, like to see to be 12 to 6. So we don't want to just change the size. We just, with this method, we just created the figure. Okay, but now inside of this figure, we have to define 2 different kind of screens. Okay, now I want to create my first screen. Okay, so now I can say, for example, ax1. ax1 means for our first screen. So ax1, now I'm gonna say fig dot. So today I want to use a new built-in function. It's called add subplot. Add subplot. Okay, this add subplot is a convenient method for creating a grid of subplots. But inside of these add subplots, we have to give it we have to pass it or let me tell you this, we have to pass it 3 arguments. The first argument is the number of rows in the grid. The second argument, or the second digit, will be the number of columns in the grid, and the third digit will be the index of the subplot. Okay, now today I'm gonna just say 1 1 and 1. Okay, so this 1 1 1, this 3 1, it means, you know, it shortened for one row, one column, and one and first subplot. Okay, so you know, one more time, you know, the first digit, you know, this is the number of rows in the grid, 1. Okay, one grid, and the second digit, the second one, it will be the number of columns in the grid 1. Okay, and the third number, the third digit, you know, this is the index of subplot 1, you know, meaning the only subplot in the grid. So with a 1 by 1 grid, this axis, you know, fills the entire figure areas. You know, just you can just minus some, you know, margins by default. You know, by default it has some margins, so we don't we don't do anything with that. So it's a standard way to create, you know, a single plot that occupies the whole figure. So we use this for the real-time beam status plot. Okay, so for the screen, for the first screen, right? So now let's go to the second line. So in the second line, we just, you know, we created our line. Okay, the line that we want to see, you know, to show us the, you know, the status of our beam, if it's active or if it's not, if it's blocked, sorry, or if it's not blocked. So we don't do anything here unless, you know, instead of AX, we're gonna say AX1 because we're doing it in the first screen. So AX1 dot plot, okay, it's empty, the color will be the same, the line width will be 2, we don't do anything, and the label will be also the same. And let's just, you know, let's delete this part because it will be too long. Let's just delete this. It's just a message, you know, it depends on you. I just say it's too long, so I deleted it. Okay, now let's just go to the second line. So the second line is our, you know, the X and Y limits. So AX dot, you know, instead of AX, now we're going to say AX1, okay, dot set lim 0 to 150, and again we're going to do the same thing for the Y direction. So we don't change anything else here. Now for the labels also, we're going to just say AX1, okay, and AX1 again here. We don't need to change anything else. Font size 14, weight bold, okay, and AX that grid, okay, nothing gonna change anymore. So AX, we turn the grid on, okay, and AX dot legend, okay, AX1 dot legend, okay, upper right, you know, the location or the position will be in the upper right, and the font size will be 10, okay. So this is for the AX1, or this is for the first screen, sorry. Now let's just go and create the second screen. So the second screen, now instead of AX1, we're gonna say AX2. It stands, you know, that we are just, it stands for our second screen. You know, in order to create the second screen, we have to just use, you know, a lower level method, you know, lower level method than this add subplot, okay, that let us, you know, manually specify the position and size of an axis, okay. So what is that, you know, lower level method? That lower level method, we can just use another built-in function. It's called, you know, add axis, okay. So add axis, in the add axis, you have to open, you know, a bracket. Inside of the bracket, you have to pass, you know, instead of, if you can remember here, you know, we passed it 3, you know, digits. Now you have pass it you have to pass, you know, 4 digits here, okay. So you know, the 4 digits, you know, the first digit, you know, is for the left position. The second digit is for the bottom position. The third is for the width, and the fourth is for the height, okay. So if I want to tell you, it will be something like this, okay, left, bottom, width, and height, okay. So we have to pass it these 4 digits, okay. So in order to pass it, you know, I want to just occupy the whole figure, okay. So in order to occupy the whole figure, so as I told you, you know, for the left, I will pass it 0. Why I pass 0? It means, that the left edge of the axis is as the left edge of the figure. Okay? So one more time. So 0, left, so instead of left, I put 0 here. It means that, the left edge of the axis is at the left edge of the figure. Okay? And again, for the bottom part, we're going to do exactly the same thing. We're going to pass it 0. It means, that the bottom edge of the axis is at the bottom edge of the figure. Okay? And now, what about the width and the height? Okay? We want to just, occupy the entire figure. Okay? So, instead of passing it 0, we're going to pass, for the width and for the height, we're going to pass 1. Okay? So width, the third digit, this one, instead of width, we pass 1. It means that the axis is as wide as the entire figure, and this height, the fourth digit, that we use it instead of height. It means that the axis is as tall as the entire figure. Okay. So this 0, 0, 1, 1 creates, an axis that completely covers the figure, exactly like, a subplot in a 1 by 1 grid, exactly like, one we did here. Okay. So, we use this method, we use this line, for the message log panel or for our second screen by creating it, by creating with this, by using this add axis. We can precisely overlay it over, the same region as AX1. Okay, exactly like this. Then we toggle, visibility with another built-in function that we're going to use. Okay, I'm going to tell you just now. But, maybe you're going to ask that why we didn't just use, add subplot. Okay, again, exactly the same method that we did here. Maybe you're going to ask why we didn't use the same method here. We could create both with add subplot, but then we would be placed in separate, grid positions. Example, we would place, the two screens side by side, but we want them to occupy, the same space, so that toggling between them feels like, changing screens. So add axis, give us, full control to position, one axis exactly on top of the other, right? So let's just, review one more time, guys, together. So add subplot, this add subplot 1, 1, 1. It creates, a standard axis that fills the figure, one row, one column. And this add axis, this add axis 0, 0, 1, 1 creates a custom axis that also fills the figure, but, is independent. Using both allows us to have two different screens in the same figure window, switching between them by toggling visibility. Okay, so now you know how to create, multi-page HMI dashboards, with Matplotlib. Okay, so now let's continue. So the next line, at the beginning, in the second screen, we don't want to see anything. So we set, the visibility to false. So I'm going to say ax2 dot set visibility. Okay. Set visible. Set visible. Okay. ax2 dot set visible. Sorry, I don't know why I made so much of mistake. Visible. Okay, ax2 that set visible. Let's just set it to false. Okay, but it's just it's supposed to be. Oh, okay, no, no. I think it's not a built-in function, in Matplotlib. Okay, I'm sorry, I just made a mistake. I got confused, just a little bit. I'm sorry. So now let's go and continue. So today, because we have LED, so we have to create our one helper function for our LED. So now let's say, for example, I'm going to say def, as usual, I'm going to call it set RGB. Okay, and I'm going to pass it, 3 arguments, R, G and B, okay, and inside the function I'm gonna say red dot right, I'm gonna pass it R, and I'm gonna say green dot right, I'm gonna pass it G, and I'm gonna say blue dot right, I'm gonna pass it B. Okay, this function was so easy. So okay, we finished creating the function, and you already know how to create this function because in previous lessons, you know, we created and we used this function, you know, so many times. Okay, now it was just, you know, a simple helper to control, you know, the RGB LED with 0 and 1s that we later gonna update in our main loop. So let's just go to our main loop and see what we have to do in our main loop. So, you know, in our main loop, for example, let's say when we run the program and when everything is normal, let's say, for example, our green LED is on. Okay, so I'm going to say set RGB. Okay, I'm going to say for the red is off, green is on, and blue is off. Okay, so it's just before everything we just turn the green on. It means that the system, you know, operating in normal condition, everything is normal and no alarm, no errors, nothing. Okay, now let's continue. We're gonna say while true is true. Okay, the first thing is to just, you know, read the data from our beam sensor beam module. Okay, and we also have another input. Okay, it's our touch sensor, so I'm gonna say touch. I'm gonna just put it in another variable. Okay, I'm gonna call it touch, and I'm gonna say touch sensor. Okay, dot read, open and close parentheses. So this is how I read, you know, the data from my touch sensor, and this is how I read the data from my beam sensor. Okay, now I'm gonna say if state is none. Okay, so instead of just if state is none, and I'm gonna add or. So because today we add I add this touch, so instead of only saying state, I'm gonna say if state is none, or, you know, touch, if touch is none. Okay, then we're gonna just say time that sleep 0.05, and then after that we're gonna say continue. So with this line, with this if condition, we just read both sensors. If any reading is none, we will wait and we skip the rest of the loop. All right, now let's say, for example, if we just, you know, touch our sensor, we want to toggle, you know, between the two screens. So now I'm gonna say if touch is true, you know, when I don't say anything, it means that if touch is true, then what's gonna happen, I want again to, you know, exactly like this line, I want to say everything, to put everything in one line. I want to say, for example, you know, go to the second screen if you know, if the touch screen is correct. Okay, and if we are in the first screen, then, you know, toggle and go to the second screen. How I can do that? I can say screen. So this is, you know, the time that I have, you know, see this screen, this variable that we created, and at the beginning we said 1. Now it's time to update this variable. So I'm gonna say if touch is true, then screen 2, active the second screen if screen equal to 1. Okay, otherwise I'm gonna say else, otherwise, you know, active the first screen. Okay, so this, you know, when I said when the touch sensor is activated, we toggled the screen variable. So if it was 1, if we were in plot screen, it becomes 2, or it becomes to the message panel. And if it was 2, or if it was message panel, it becomes, you know, the plot, it becomes the first screen. And let's just add, you know, debounce, you know, option. Let's just add, for example, like time that sleep for, like, for example, 0.3. You know, this is a debounce to prevent, you know, multiple toggles, you know, from a single touch. Okay, So this is how, with these, three lines, with these three lines, we just defined, we just said if we touch our sensor, just, toggle between two screens. Okay. Now let's continue. So here we said, here it's where we converted, the Boolean to 0 or 1, and we append here, we append, to the rolling buffer. Okay. But, as you can remember, we removed the time history, so we don't need it here. Okay, we remove it here as well. Okay, now let's just go to our beam logic or edge detection. So here we said if not state and not beam blocked. Okay, beam blocked equal true, object count plus equal 1, block start time equal time that time. Now it's after that, let's just add our RGB. Okay, let's, for example, we want to turn let's call our RGB module first. So set RGB. Okay, so set RGB, let's, instead of just for example turn like only blue on, let's just keep, blue and green, because the combination of green and blue, it gives us, a cyan. Okay, let's just turn both of them on, so it gives, a kind of, cyan color. So let's say, for example, red will be off, but green and blue, both of them will be on. Okay, so it means that object detected, so it becomes cyan. Okay, and at the end it will just print a message. Okay, it says object detected, total count, and object count. Okay, now we don't need this LED anymore, because in previous lesson we only had one LED, so we're gonna delete it. All right, now let's come to the next line. We said, elif state and beam blocked. Okay, we said beam blocked false, we don't need to change. Okay, everything's okay. And block duration. So now here, instead of this block duration, okay, let's just only say duration. Let's just call it only duration. Okay, so duration equal time that time minus block start time. Okay, and now I have to add another if statement. Okay, because I want to say, for example, if the sensor doesn't get blocked, or if it doesn't sense any object more than 2 seconds, it means, for example, that our conveyor is stopped, or for example it means that we missed an object. Okay, we missed our product, our goods, because our sensor doesn't sense anything, doesn't no object blocked our sensor. So we want to just send an alarm. Okay, so now I have to use an if condition here. Sorry. Okay, duration, this is the duration, I just deleted it. Okay, so here after this duration, now let's say if duration greater than, I say 2, but it depends on you. Okay, it depends completely on you. For example, you can say 1 second, you can say 3 seconds. I just say 2 seconds, I think will be enough, will be good. Okay, so if duration greater than 2, then what's gonna happen? Then we're gonna update this, let me see, this variable here. If you can remember, I told you we have, we want to count our errors. Okay, so here now I'm gonna update this variable. I'm gonna say errors. Now I'm gonna just add it 1. Okay, so I'm gonna say plus equal to 1. Okay, plus equal to 1, and after that, okay, again, if you can remember, we also had this. Okay, this message. So now we have to append another message to this message that we had. Okay, so what we have to append here, so after this line, okay, so after this error, I'm gonna say messages dot append. So what I want to append to this message, I want to say, for example, first of all, I want to use the f string, because I want to show the duration this duration because I want to see this duration in my message. So I'm going to say message that append. So f string, now I'm going to say alert, okay. And after that I'm going to say, for example, object, let's say not object state, let's say, for example, system stopped or system stock. Okay, it doesn't matter what you want, what message. I just, it depends on you, what kind of message you want to see. I said, let's say, for example, system stock. Okay, and after that I want to see the duration. I'm gonna say duration, but I want to see, 2 digits after decimal point. So I'm gonna say, I'm gonna use column, and I'm gonna say dot to f. Okay, and after that I'm gonna add an s. So this s, stand for example, second. Okay, so s stand for second. So this is this is for our message. But this is for our alert, this message for the time that we encountered an alert. Okay, but we also have to print, I want to print a message in our elif condition. Okay, so in order to print a message in our elif condition, we also again have to use our append function. Okay, how we can use it? Again, we're gonna update our messages, this variable. Okay, I'm gonna say instead of print, let's say messages dot append. Okay, but what we want to append to this message? Now let's say if object passed and duration, we're gonna say instead of block duration, now we're gonna use our new variable. I'm gonna say duration again, 2 digits, after decimal, and instead of sec, let's say s. Okay, stands for seconds. And after that, I want, for example, our green LED to be on. Okay, let's say set RGB. Okay, just be careful, this is in our elif condition, not in if. Okay, so set RGB, so red will be off, green will be on, blue will be off. Okay, and we're gonna remove this LED.write, we don't need it. Just in this condition, let's just turn our buzzer off. We want our buzzer to be off here, so I'm gonna say buzzer that write 0. Okay, so this is for the buzzer and this is for the RGB LED. Okay, so what we did here, guys, let's just review quickly. Let's say, for example, beam just cleared. We hear that the beam is cleared. I mean that the state is true, and we were, previously blocked. So we will reset. We will reset this beam blocked. So it become false again, and we calculate, how long the beam was blocked. The duration. We're gonna see all this information in our seconds screen. And if the duration exceeds 2 seconds, increment the error counter and add an alert message. I mean, for example, if our sensor doesn't get blocked, if our module doesn't get blocked for more than 2 seconds, it will just start sending an alert. And we always add a message with the duration here, message with the duration. And we change the RGB here to green. And we ensure that our buzzer is off. Okay, with this buzzer.write. This is how we just we write this part with this condition. Now we can just go and continue. Let's just say what we have to what else we have to do. Now I think we have to just create our alert for for example system stock, for example, for the time that our system is stock, or our sensor doesn't block with any object. Okay, how we can do that? Let's just again use an if condition. I'm gonna say if now I'm gonna say if beam blocked. Okay, if beam blocked is true. Okay, yes, because here in this elif, okay, yes, it's correct. We have to say if beam blocked is true, and we want to say if the time is more than 2 seconds. So we have to use and. Okay, so and what? And I'm gonna say time dot time, open and close parentheses, minus block start time, block, why it's just block start time, I don't know. Yes, block start time, I don't know why it didn't show me. So okay, minus block start time greater than 2. Okay, now what gonna happen? I want to, our red LED to be on. Let's say, for example, set RGB, red is on, and the other two color will be off. And also the buzzer, I want to turn the buzzer on. Buzzer that, right. If you want to become more, interactive, if you want to make it more interactive, you can, for example, create another function for your buzzer, and instead of just, creating a continuous beep, you can just create, like a wave sounds. For example, 3 times, it can beep. It just depends on you, but because I wanted to keep it, as simple as possible, I just say, let's make, a continuous beep. Okay, so if the beam is, if the beam is not blocked and the time, since it was not blocked, exceeds, 2 seconds, we trigger, the alert, the red LED and the buzzer will be on. This runs, continuously while, the object is not blocked our sensor. So if the object blocked the sensor, everything will reset. Okay, I think now it's finished here. Now it's time to just, update our screens, because we have 2 screens, so we have to update our screens. Now I can just come to the next line here. Okay, on top of this. Now I want to say, for example, let's start with the first screen. Okay, so let's say if screen equal to 1. So if we will be in our first screen, I want to see, the first screen completely, but I want to just, the second screen to be completely, invisible or not visible. Okay, so I'm gonna say ax1 dot, I'm gonna say set visible. Okay, set visible. So for the first screen, I'm gonna say true. Okay, when we are in the first screen, we want the first screen to be visible, and the second screen, we want it to be, completely, invisible. So ax2 dot set visible. Okay, now I'm gonna say it will be false. Okay, and for the now, let's update the first screen. In order to update it, for our line status, it will be exactly the same like this. Okay, so it will come here. We don't need to change anything here. It will be the same. And also, instead of for the x and for the y, for the x limit, just instead of ax, we're gonna say ax1 dot set lim. So this one will also come here. Okay, now we just need to update, our yes, this is for the x limb. Yes, now let's just do exactly the same thing for the y limb. Let's just see if we did it here. I think ax1 that set y limb here. Okay, so we did it here, so we don't need to do it in the main loop. Okay, so ax1 set x limb 0 max, that's fine. Okay, this is for the first screen, and now instead of now we don't need anything else here. Okay, so this is for the first screen. Now in the second screen, because we have everything will be new, so we don't need all this information. So I'm gonna say else. Else means, if screen equal 2, or if it not equal 1. So now let's say, for example, I'm gonna do exactly the same thing here, but with this different, that this time I just copied and paste them here, but this time the first screen will be false and this the second screen will be true. Okay, so ax2 dot set visible true. And again here let's set our face color to, for example, let's say ax2 dot set face color. Okay, now I'm gonna use again, you know, the same method that I used in and I taught you in previous lesson. So instead of just, you know, writing down the name of the color, I can just let's go about, okay, see here, so I can just easily copy. So I can copy this line, this part from the hash. Just hash is very important, don't forget to copy the hash, and I'm gonna paste it here. Okay, so instead of just red, I'm gonna say I want it to be black. Okay, so this is for the face color. Next, let's just say we want to clear the access. We don't want to see anything, we just want to see a blank page. So I'm gonna say ax2 dot clear. Okay, so this will clear the access. And what else we need here? I don't think we need anything else here. So now let's just for the messages. Okay, now let's just tell our program that we want to just print and see the messages in our screen. You know, in order to print the messages in our second screen, we need to use a for loop. Okay, but I want to just introduce a new Python built-in function to you. It's called, you know, enumerate. Okay, you know, if I wanted to use just, you know, normal for loop without using just, you know, enumerate built-in function, I should have say, you know, for example, I equal to 0, and then I should have come to the next line and say for example, msg in messages. Okay, now I can say, for example, whatever I wanted to say, because I wanted to just print messages and I wanted to keep them. I could say I plus equal to 1. Okay, but with the enumerate, you know, with the built-in function, as I told you, with the enumerate built-in function, we can do, you know, we can do this this operation in a very concise, much more concise way and much more cleaner. Okay, so but you know, the enumerate, let me just first of all let me write it down, and then we will just break it down together. So now in for loop, I'm gonna say for I. Okay, so for I, I'm gonna say comma, and I'm gonna say msg in enumerate. Okay, enumerate, and I'm gonna pass it messages. Okay, but you know, what is this enumerate? What is this built-in Python function? You know, enumerate is a built-in Python function, as I told you, that takes, you know, an iterable, like, you know, a list, tuple, or deck, and it returns, you know, an iterator of index and value pairs. Okay, it allows you to loop through a sequence, you know, while keeping track of the position of each, you know, item. As I told you, you know, instead of writing the line like this, you know, if you can remember it, I wrote it down for you just now. So instead of writing like this, I can say, for example, I equal 0 for message in messages, I plus equal 1. Okay, but if you can see, if you compare this, you know, kind of writing with this kind of coding or writing, you can see how cleaner and how concise this way is. Okay, but you know, how it works here, how this enumerates, you know, work here, you know, just imagine these messages. The messages, as I told you, if you can remember, it's a deck. So it's a deck that containing, you know, the last 10 event messages. For example, like, you know, we want to print, you know, object detected, total count 1, or object passed, duration, for example, you know, whatever seconds, or etc. Okay, when we loop it with this enumerate, messages, when we loop it with this, the first iteration, it gives, I equals 0, and the message will be, for example, object detected and total count 1. The second will give, I equal to 1, okay, instead of 0, so it will just, add it one by one. So I equal, then after 0, I will be equal 1, and after 1 will be 2, will be 3, and, so on, okay? But maybe you ask, why do we need the index I? Okay, the index of I, because we need it in for the next lines, in our coding. So let's just go ahead, let's go forward, and when we reach to that line, I'm gonna explain to you why we need this I indexed. Okay. So we inside this for loop, we just created the for loop, but inside this for loop we want to just print our message. We want to just tell the program that we want to print a text with, for example, in this we have to give it the coordinates, the font size, the color, and everything that you can remember from the previous lines. Okay, so now I'm gonna say ax2, okay, because we are in a second screen, so ax2 dot text, okay, dot text. So now I have to pass it the coordinate x and y coordinate. The x will be the same for all messages, and for example, like let's say for example 0.01 for the x coordinate. Okay, maybe you just say, maybe you're gonna ask why we just set 0.01. It's just a small offset from the left edge, because we don't want to just completely start from the left, exactly the left. We just give it a small offset. It depends on you. If you don't want, you can just ignore it, but it's better to give it a small offset. Okay, so the x coordinate, as I told you, will be the same for all messages. But we have to just define the y coordinate, because the y coordinate, we see the messages vertically, because they just print in our screen one by one after each other. Okay, but how we can tell the program to just move the text downward? How we can do that? We can just write a very simple formula. I can say, for example, let's say 0.1 times what? Times this I. So we're gonna use the index of I here, so time I. Okay, so this 0.1 time I, it moves the text downward by 0.1 times the index. So the first message will be I equal to 0, is placed at y. Recent message appears at the top if we appended in order. The last message is the top. Okay, and in our case, because we use a deck with max length 10 and append new messages, the order is from oldest to newest. Okay, so the loop will print them from oldest at the top to newest, lower down. Lower down. So you could reverse the order if you wanted, the newest at the top. So it depends on you. It's just the way that I am doing for today's lesson, but as I told you, you can just reverse it and you can just set it the way that you want. But if you can remember, if we are just using the axis coordinates. So we have to tell the program to give it a number to represent the top of the axis. Okay, so in order to do that, we can just use a 1 here. Okay, we can say 1 minus 0.1 time I. So this 1 represents the top of the axis. Okay, so this is for the x and this is for the y coordinate of our text. Just let's review everything for this section so far. The enumerate, this Python built-in function, it gives us both the index and the value of each message. The index I, this I here, it used to position each message vertically on the screen, and this creates a simple auto formatting log panel without having to manually calculate positions. Okay, hope you understand this part guys properly. Please just don't hesitate and just let me know if you have any question, if you don't understand any part. I will explain it to you in more details, but I don't think it's that much difficult. Just try to watch the sections that you cannot understand it more and more. But if you can understand it, then just please just let me know. I will explain it to you in much more details. So what we want to see here, we want to see this MSG. We want to say the message, so we're gonna pass the MSG here. Okay, and what color we want it to be. For example, we want it to be let's say in white, so I'm gonna say color equal to white. Okay, oh sorry, just I forgot the equal sign here. Okay, so color equal to white. Okay, and the font size, for example, font size will be equal to like 12. Okay, so font size will be 12. And what else we want to see? Just I have to explain to you about one more thing. The coordinates in the coordinate system in Matplotlib, when you place text or any other objects on an axis, Matplotlib needs to know where to put it. There are several coordinate systems. We have data coordinates, or for example we have axis coordinates. So what is data coordinates and what is axis coordinates? Data coordinates is the default the points are specified using the same units as your data. For example, if your plots x-axis runs from 0 to 100 and y from 0 to 1, then for example if you say ax2 dot text for example 50 and 0.5, and then you want to print a hello message, it would place the text at the center of the plot in data units. But in axis coordinates it normalized to the axis area. The bottom left corner of the axis is 0 0, the top right corner is 1 1. This is independent of the actual data limits. Okay, and in our message panel we don't want to rely on data values. We want to message we want the messages to be placed relative to the axis to the axis area itself. For example, the first message near the top, the second slightly lower, and etc. So in order to do that, we need to use something called axis coordinates. So using axis coordinates makes this easy for us. So we can specify positions like 0.01 and 1 for the top left, and 0.01 and 0.9 for a little lower, and so on. You can just do that. So this the part, this 1 minus 0.1 times I, as the code uses this part as the y coordinate. This yields values like 1.0, 0.9, 0.8, and so on, which are perfect for stacking messages from the top down. Okay, so I want to use something else here. It's called transform. Okay, how I can use that? I can say transform. Okay, so sorry, transform equal to, so I'm using it in our second screen. So ax2 dot, I'm gonna say trans axis. Okay, so ax2 dot trans axis. So what is this ax2 dot trans axis? This is a transformation object that maps axis coordinates from 0 to 1 to the actual pixel coordinates of the axis on the screen. So when you pass transform equal to the transfer equal to ax2 dot trans axis, you are telling Matplotlib like this: interpret the x and y values I provide as axis coordinates, not a data coordinate. Okay, so using this trans axis ensures the text is placed exactly where we want, a relative to the axis panel, regardless of the data range. So again, about this transform equal ax2 dot trans axis, let's just review everything quickly. This transform equal ax2 dot trans axis, it switches the coordinate interpretation from data units to normalized axis units. Also this allows us to position text relative to the axis panel itself, making the layout independent of the data. And it is essential for creating clean HMI panels where you don't have meaningful data scales. Okay, so let's just continue. And so the next thing, we need to just set the x and y limit for our second screen. So I'm going to say ax2 dot set x lim. Okay, for the x, I'm going to say, for example, only 0.1. Okay, and for the y, ax2 dot set y lim, I'm going to say again 0. Sorry, I don't know what it says. 0.1, 0 comma 1 and 0 comma 1. I made a mistake, sorry. So 0 comma 1 and 0 comma 1 for the y. Next thing, let's just hide the axis, yes, because we don't want to see any axis. So I'm going to say ax2 dot axis, I'm going to say off. Okay, so I don't think anything else left. Now we can just go and just adjust the whole style adjustment. This was just for our axis. Now the whole figure, we want to make also the figure also black, I mean the background. So now instead of just making it for one of them, we're gonna use in for loop, so we're gonna apply it for both screens. So I'm gonna say for ax in, now I'm gonna say ax1 and ax2, instead of just doing it separately for both screens. With for loop, with one for loop, we just do everything for both screens. So let's just set ax dot set face ax dot set face color. Okay, we want to see, for example, let's just again copy and paste this line. Okay, hash, I don't know what. Okay, yeah, I forgot the code mark, the HMI mark. Okay, so this will be black. So set ax dot set face color will be black, and now the whole the whole picture we also want it to be black. So I'm gonna say fig dot patch dot set face color. Again, I'm gonna just paste the above color, but don't forget the hash. So hash the color. Okay, and let's say the tick params. Okay, now ax dot tick ax dot tick param. Okay, ax dot tick params, I want it to be like, let's say, white. Okay, this one will be white. So ax dot tick params. What else? Oh, labels. Yes, the color of the labels. Ax dot x axis. Okay, x axis that label that set color. I'm gonna say again white, and we're gonna do exactly for the y axis. Y axis that label that set color. Okay, again this one will be white as well. What else we want to do? Okay, so we want to say that if the axis has titles, we want to see the titles in white. Okay, if there's titles, because our first screen we have titles. So I'm going to say if if AX, okay, yes, so if AX dot title, then we're gonna say AX dot title dot set color. We're gonna say again this one also black. So what did we do here, guys? We apply, you know, a consistent dark theme to both, you know, axis and the figure, okay, with these two lines, you know, axis and the figure both will be dark. This is done, you know, in every loop to ensure it, you know, persists, you know, after cleaning AX2, though it's, you know, unnecessary for AX1 after the first time, but you know, it's just harmless. Let's just do it for both of them. Okay, now let's just, you know, refresh and delay. Okay, so we're gonna say plt.draw. okay, so plt.draw, plt.pause, and time.sleep 0.05. okay, now I'm gonna say yes, we wrap this, you know, try and accept block in another try and accept block. Okay, and oh, so instead of this LED dot right, okay, now here let's say set RGB, okay, 0, this one 0, this one 0, and this one also 0, and let's just turn our buzzer also off. So I'm gonna say buzzer dot right will be off. Okay, and plt.close all, board.exit. okay, and except, we pass the except, and we're gonna print a message at the end, program stopped safely. Okay guys, I don't think that anything's left here. I just let's just go and run the program and see what's gonna happen. So I press run button. Oh, it shows an error, guys. It says line 106. I just hope you shouted. I don't know why I made the, you know, I just typed down so quickly. I just made a mistake. So y-axis. Okay, sorry for that mistake. All right, let me just run the program one more time. Okay, so this is oh, it shows another error. Why it says I don't know, it errors. Yes, I think we made another mistake here, guys. I'm sorry. Errors, you know, errors, S. Yes, errors, not errors. I forgot to put the S. I'm sorry, guys. Let's just run the program one more time and see what's gonna happen. Okay guys, see, perfect. Yeah, and so as you can see in your HMI, let me just minimize it here. Let's make it smaller so you can see both screens. Okay, okay, so see, this is the light beam object detecting, you know, real-time monitoring sample. Okay, so now I blocked, you know, the sensor. Okay, now let me unblock it and wait for 2 seconds. Yes, see the error, the LED is red and the buzzer, you know, continuously beeping. Now let me block the sensor. That's great. And let me touch the sensor and let's toggle between the screens. Okay, oh, that's great. See, this is the second screen, and read the messages. Object passed, duration 12.2. Okay, now yes, see, alert system. Okay, oh, just, you know, system stck, I just forgot to put the U there. Okay, let's just go and correct it. Let's just go to our message, where it was, system stock sorry, I forgot to put the U here. Okay, so let's go and run the program one more time and see what's gonna happen. Oh, it's just why it shows an error. Let's just, we didn't change anything. Let's oh, it's working now. Oh yes, it's working. I don't know what happened. Just yes, that's per. Let's just now toggle between the windows, between, sorry, the screens. Okay, that's perfect. See, now let me just continuously see. I am just continuously blocking the module. Yes, see, now it's green when the when I am just blocking the sensor, the green LED is on, and when it's normal, it's blue. Sorry, I mean it's cyan. And when it is, oh, okay, when it is in alarm, state, it become red. Now it's green. Now it's cyan. See? Okay, that's perfect, guys. So you can just change the colors, it depends on you. So, maybe for example, you want to see, the blue color or the green color when the system is normal or whatever. It just completely depends, and it's not a big deal. It's just, the color of the LEDs, but the system works perfectly. See? Okay, now let's just wait. Okay, now let's block the sensor and see the duration. Okay, see? Alert system stock for how long? 6.25. Okay, now the object passed and it shows us the duration, 6.25. Okay, see? That's great. And let's toggle between the screens again. Sorry, I didn't touch. Okay, see? Yes, and now that's working. That works perfectly. That's worked perfectly. And you can do it, exactly, opposite. For example, you can put the alarm when, for example, when you block the sensor, for example, for more than 2 seconds, like what I do here, you can just set the alarm. But I just, for this demo, I just, I did that. Okay, it's working perfectly. Now let's toggle between the window, between the screens one more time. Wait, let me, oh, okay, now it's good. Okay, see, one more time. Okay, see? Yeah, oh, wait, let me just make it a little bit smaller so you can see everything perfectly. Sorry guys, I didn't see that. You can't see. Okay, let's just do it one more time again. So now let me just toggle between windows, between the screens. Sorry. Okay, see? When I touch the sensor, okay, and this is the first screen. This is the second screen. This is the first screen. This is the second. Okay, so you can just toggle between the windows. So for example, for the first windows, you can just see, the overall, status of the system of your machine. Okay, and in the second screen, you can just see the errors, the messages, or whatever you want to see and see. Okay, now see, you can hear the buzzer is on. Okay, that works perfectly. Let's just try our Control C button. Okay, let's press Control C. Yes, see, program stopped safely. Shutting down, program stopped safely, and everything is off. Our LED, our buzzer. So the program is working perfectly and nothing's wrong. So hope you just like this lesson and you enjoyed today's tutorial. Please let me know if you have any question or if you have any doubt. See you in the next lesson.